Hi everyone, and welcome back to Dyslexia in the Elementary Years. This video will focus on the science of dyslexia. So let's go ahead and just jump right in. You'll notice that the first two areas we'll be discussing are brain function and brain structure. So let's go ahead and jump into brain function. So this chapter is really focusing on the different areas of activation in the brain when someone is trying to read. So, if you watched my previous video that's all about the characteristics of dyslexia, you might remember this image. So, you will see that a typical reader has multiple areas of activation in the brain as they attempt to read. And then with a person who has dyslexia, there is only one area on the left side, the left parietal temporal region is what it's called, that gets activated. So because of this reduced activation, that is really what causes the phonological disability for a person with dyslexia. So this is what it looks like in the brain, and that lack of activation in key areas is really the root of dyslexia. So the brain functions in a much different way if you are a person with dyslexia. Additionally, scientists have found that not only the function, the activation in different areas, not only that function of the brain is different, but also the actual structure itself appears to be different based on some neuroimaging that has been done. So, the first difference I'd like to focus on is gray and white matter. So, gray matter processes information and white matter transmits the signals. So, you might think of the gray matter as a variety of structures or homes, and the white matter would be the roads that connect those areas. So, individuals with dyslexia have shown less gray and white matter in that left parietal temporal zone that we were talking about previously. So it's not just that there's a lack of activation, but also that structurally they just seem to be built quite differently. But as we'll talk about in a different video, it is actually possible with the use of very targeted interventions to promote more activation in those zones with targeted practice. So the other key structural difference is hemispherical asymmetry. So there was this really interesting study that showed that in most, so actually, I'm going to guide you to this picture really quickly. So this image right here is an image of the brain taken from the front. So you're going to see that there's a left hemisphere and a right hemisphere. And as we've already talked about, so much of the reading work that's done is in that left parietal temporal region. What this study found in 2004 from Heim and Kiel is that most people who are non-dyslexic and right-handed will have a larger left hemisphere than right hemisphere, which is quite interesting. And then conversely, if you are a person who is also right-handed, so they were comparing, people who are right-handed, non-dyslexic, and right-handed dyslexics. So a person who is right-handed and has dyslexia actually showed the inverse. So rather than having a left hemisphere that was larger than the right hemisphere, which that left hemisphere, again, is where so much of that reading work occurs, a person who's right-handed with dyslexia showed either that the hemispheres were equal in size, that they were symmetrical, or the opposite, that the right hemisphere was actually larger. So this structural difference actually offers a bit of an explanation as to why dyslexia may occur. So if you've watched the characteristics video, you will have maybe remembered that individuals with dyslexia often will recruit the right hemisphere of their brain and or their frontal lobes as they're trying to read. And this might be due to this asymmetry and the structural difference. If their right hemisphere is larger, they're kind of recruiting that side of the brain as they're trying to decode, which is a really wonderful adaptive strategy, but it isn't as efficient as using those left parietal temporal regions. Next, we're going to talk about heritability. So, the research is showing that dyslexia does run in families and that it has a heritability rate of 40 to 60%. And what that means is that if you have a person in your family with dyslexia, you are at greater risk of having dyslexia yourself. So, if you're a parent out there and you are concerned that your child might have dyslexia, it is really important to know if anyone else in the family might have dyslexia because it really is. It's genetically linked, particularly because this is a neurological disability. So next we'll focus on neuroplasticity. So neuroplasticity is the capacity of the brain to build new connections. And this is really important to the science of dyslexia because all of this great neuroimaging that we now have has also shown us that we can actually rewire the brains of a person who is dyslexic. So study after study after study has shown that phonetically based interventions have proven to be effective for students with dyslexia. So what you will see in this image right here is so right on this side, it will say the right hemisphere, and over on this other side, it says the left hemisphere. And this is a person who has dyslexia. And on the top, it's the right hemisphere and the left hemisphere. It's kind of flip-flopped, sorry. The right hemisphere and the left hemisphere of a person with dyslexia before intervention. That means a phonetically based targeted reading program. And then what their brain looked like after intervention. So what you can see here is that before an intervention, the brain of the person with dyslexia was showing great activation on the right hemisphere. Remember, that's the less efficient place to process reading and sounds. And then they were showing very little activation on this left hemisphere. Conversely, after the intervention, it is showing that the right hemisphere was activating quite a bit less than before, and that they really fired up that left parietal temporal region. This is incredible, and it's crucial to how we treat individuals with dyslexia. And not in this video, but in an upcoming video, we will talk about very specific interventions and ways to target individuals who have dyslexia so that we can help to rewire their brains and really capitalize on that neuroplasticity and ultimately help them to become readers and improve their outcomes. In addition, neuroplasticity is really important when you're talking about early intervention. So, early intervention capitalizes on neuroplasticity. So, young kids, as I'm sure we all have seen, they're just like little sponges and they can be very resilient and adaptive. So, when you do early intervention, you capitalize on that neuroplasticity by building new connections earlier on when their brains are just quite a bit more malleable. This also catches students before they fall. So students with dyslexia will often avoid reading because it is so hard and so challenging and upsetting that they will avoid it. And in that avoidance, it actually perpetuates the issue, and then they grow farther and farther behind their peers. So the earlier we can catch these students, the smaller that gap will be between dyslexic students and their typically developing peers. Because of this, early screening is key. So again, in a different video, I will go into more resources and the next steps you should be taking. But just know that if you are concerned about your child, getting them screened as early as possible is really going to deliver the most benefits to you and your child. I do just want to focus on a few quotes from the experts. So Sally Shayowitz is one of the leading researchers on dyslexia. And she says, the human brain is resilient, but there is no question that early intervention and treatment bring about more positive change at a faster pace than an intervention provided to an older child. The sooner a diagnosis is made, the quicker your child can get help, and the more likely you are to prevent secondary blows to her self-esteem. So that's not to say that an older child cannot benefit from intervention, because absolutely an older student can benefit from these supports. But this really is making the case that the younger you can get intervention for your child, the better. So if you have a preschooler or kindergartner or first grader that the teacher is concerned about and they're really lacking in their skills, please, please, please listen to that person, because it's very hard to have these conversations anyway, for the teacher. And so if they're bringing something to your attention, it really is something that they are concerned about. And the sooner you act on it, the sooner your child can get help. Additionally, the Harvard Medical School writes, up to 70% of at-risk children who receive educational intervention in kindergarten or first grade become proficient readers. So again, if you can get that early intervention, you really, really improve the outcomes for your child down the road. And again, if you have a child who's maybe in fourth or fifth grade and you're concerned about this, it is never too late. All right. Next, a final note, and this is very important. So you will notice in all of the research that I presented here today, not once was there any sort of comment about a person's intellect. So you will notice that all of these images that I've shown you today really just show one specific area that has a very specific disability. It is strictly phonology. It does not affect the intelligence of the individual who has dyslexia. There has been a study by the National Institute of Health in 2011 that showed dyslexia is not tied to IQ. It is not at all a judgment of a person's intelligence. It strictly is a phonological disability. And furthermore, there are many, many, many famous people who are incredibly successful and brilliant who have dyslexia. They include Charles Schwab, Richard Branson, Octavia Spencer, Anderson Cooper, Steven Spielberg, Einstein himself, which I didn't know that one. I was like, wow, if that's not a case that it's not a judgment of somebody's intelligence at all. It's just a phonological disability. And also F. Scott Fitzgerald and Agatha Christie. You'll notice a few of those people are writers or reporters. And so, despite this phonological disability, they have been able to pursue careers that heavily are involved in literacy. All right, so that's all for this one. Thanks so much for tuning in, and I hope to see you on our next video.